Can you hear me, Russ?
I can hear you just fine.
Thank
I'm
you.
glad you made it into the meeting.
Now I have a responsibility to come.
Hello.
Welcome.
How you doing, Ross?
Glad you made it today.
My favorite topic.
I know it's your favorite topic. We'll wait about 5 minutes for people to join and we'll get started.
Your slides all done for the summit, Ross?
Working on it.
Yeah, me too.
So we'll get started in a couple minutes after everybody has time to join. This is the first meeting after switching to Zoom. There are probably people who are struggling to get in, but they'll get in soon, hopefully.
Well, you're doing better. The sustainability project team call, I don't think happened yesterday. So
Sorry, I'm getting all the texts of I'm trying to figure out what's going on with, I'm trying to get into the meeting and I'm confused.
Yeah, as John said, it's been worse than some other groups. John Michael, I should say.
I'll give it 2 more minutes and then I know we're starting a little late today. But feel like I'm a secretary trying to run a meeting and do text at the same time about how to get in. Okay, maybe we'll get started here and other people can join as needed. So welcome to our meeting today. I just have a couple of announcements. The first is, remember OCP Global is coming up and I encourage you to go. Next, I want to make sure everybody is aware that Mike Allison is our new IC representative for storage. And that is also being renamed to the, I believe the steering committee, if I get this right. Mike, do you want to introduce yourself for 1 minute here?
I'm from Samsung and been working in OCP and NVMe and a whole bunch of other standards, and I'm sure I'll have a lot more documents to read now.
So Mike, it's great to have you on board, and I'm sure we'll give you lots of great work.
Congratulations and condolences.
Thanks, Lee.
How you look at it, yeah.
And with that, today we have Jeff Anderson from Google. I think I saw you on. You are here. He has a presentation on security for us today. So Jeff, you want to take it away here?
Sure. I don't have slides, but I don't think that'll be a problem. I hope. Just talk about it. So thanks all for having me. The high level place I'm coming from right now is how attestation is going to work. Basically SPDM is going places. Devices are attesting their firmware. There are, I'm speaking from a hyperscaler perspective. There's a gradient of priority where we care about these attestations. So things which directly touch user data are the most critical. Then storage devices are on that spectrum, and then eventually we want to attest to fan controllers and whatnot. Although that's kind of important because of availability. Anyways, storage devices is going to test their firmware. And what is that going to look like in our flows? So we can have devices, if we do nothing, I think that the way things are trending is devices will show up, they'll be storage devices, and they'll have an SPDM responder within them, and we can challenge that from our control plane to get attestations of the integrity of the firmware. Now, there are different ways of slicing that. The way Google does it, and we've presented this to OCP, is that we have a central verifier, and we have been working in the standards bodies to develop plumbing to expose SPDM from devices all the way to the control plane through, currently we have, there's Redfish bindings. So if the SPDM device is behind a Redfish service, there are Redfish actions you can invoke, which will expose the raw SPDM bits to the remote verifier so that we can directly validate those. So how do we latch that into an end-to-end flow? Well, we can periodically ping the device and make sure that it's running up-to-date firmware. But if that's all it can do, then that's all it can do. So what about when we want the device to do something like erase itself? So if you want to combine attestation with that flow, it seems like there's a little bit of a decoupling going on where you can issue a challenge to make sure the device is running clean firmware, and then you can issue a follow-up step to say, okay, now go do the thing, erase yourself. And there's not really a tight cryptographic binding between those two activities. It's not the biggest of deals, but it does seem like something we can get in the works to try and tighten up. So that's where my proposal has been coming from. And this is, initially we discussed this in OCP security, say, what if there were a vendor-defined SPDM action or command, vendor-defined in the sense of SPDM, but it would be an OCP standard thing. Say, go do crypto erase, and then issue me a signature saying you've done it. That was a bit heavyweight, and in fact is probably more heavyweight than we need. Someone came up with a neat optimization to say, why can't the SPDM responder just report whether or not there has been any data written since the last time it was erased? then attestation normally in the control plane, like in day-to-day activities, doesn't care about that status bit because of course data is there, that's what they're for. But when you're trying to erase the drive, you can erase it and then make sure, okay, yep, clean firmware says it's clean of data. This device is good to go, we can now repurpose it. So that is the long and the short of the pitch.
So you're saying erase. How does that apply to IEEE 2883 purge type requirements?
I don't know. That's a very good question.
And when you say erase, is that through SPDM or NVMe MI or, I mean, NVMe, or what's the
Yeah, so-
protocol for doing the erase?
I was hoping not to have to get into the weeds of teaching SPDM how to do erasing, because I understand there's a whole protocol for that, and SPDM is not typically used for that, and I don't want to have to change the world that way. It would just be, SPDM would just be reporting statuses of here's my firmware and here's whether I have any dirty data in me.
Yeah, Jeff, I think some people got caught up on the crypto race, but IEEE Purge defines overwrite, block erase, and crypto erase as the 3 techniques you can use for a sanitized purge method. And, I think that's in the spec as 3, different devices like hard drives will support overwrite and SSDs will probably support block erase and crypto erase. Older drives that didn't support NVMe sanitize can support an NVMe format with crypto erase, and that is a technical IEEE 2883 compliant purge, but older drives that don't have the NVMe sanitize command may not support that, and so that's pretty well defined in 2883. So that was our, I guess, first feedback was just making sure the language, making sure the language is consistent, that we use the word sanitize, and then the 3 techniques that are described.
Makes sense. And it sounds like then I'm spitballing here off the cuff. Maybe if we go this route of having SPDM status bits, we could have maybe 3 status bits. Has any data bit written since the last overwrite, since the last crypto erase, and I forget the other one.
Yeah, and then the other thing we described is in the spec, there's an optional verification where you can either write a known pattern to 5% of the LBA range, which is a partial verification, and then read that data back and make sure it's either the known pattern that was overwritten or the expected data. Obviously, that's hard on a crypto race because the expected data when you read it back can be random data. So there is some talk about how you do how drive firmware does that overwrite after a crypto race. For instance, if somebody wants to actually read back the LBAs and make sure that they have not been trimmed or deallocated and that they're actually reading data from the flash. And so that's part of this flow for verifying that all the user data is gone.
Okay.
So these software tools will basically do the sanitize crypto erase and then read back the known patterns.
So the NVMe sanitize actually has a way to say, yep, I am sanitized and no user data has been written to me. But if you do the format NVM command, I'm not sure if that's going to be set or not set in the spec.
Yeah, it sounds
I
like
don't think that it is.
I don't think it is too, because I don't think you can change the sanitize status log page.
It is.
Well, and I think the real problem is that the sanitize, none of that is, unless you do it over a secure session. I think the whole point of this is that it's an SPDM cryptographically attested communication so that you can't spoof that man in the middle and have something that says, oh, it was sanitized, but it really wasn't. And you have to do that through some type of either secure session and which might be a way to do it is to establish a secure session and then do it with your own NVMe standard methods versus doing it with a additional bit in SPDM. I don't know if you guys have thought about that method.
Yeah, I was looking along just those lines. If the way I do if the way I do sanitize is write a bunch of random data and read back and make sure it's different, then I think to leverage SPDM, it does all need to be in an SPDM session, which drastically raises the bar on the legwork needed to actually get that thing working.
That
There-
doesn't have to be the way it's done, right? That's one
Yeah, right,
method if you wanted to validate it. You can throw away the key, right? So you can do a sanitized crypto erase where you just throw away the key and then say that's done. And then I think there's lots of different measurement attestation techniques or types. I don't know which bit specifically you were thinking of trying to set or create a new bit where in SPDM that would indicate, here's this new way to indicate this. But I think with all the different measurements that are available, I wonder if there's something within that could say, this is a new measurement type or something that indicates a completed sanitize of a purge level quality. And then I think all the other mechanisms I think would be something that could be done alternatively, either through a secure session and then use the existing NVMe capabilities. I think those are two totally different pathways that might be able to be used to achieve the same thing.
Yeah, let me just pull up SPDM.
Well, I want to make sure you understand also that the difference between a sanitize and NVMe and a format. The sanitize says all data in the namespaces plus any data outside the namespaces, like stuff that's been written to the NAND that hasn't been erased, has to go away. Where in format NVM, I don't think that's the requirement. You just have to get rid of the data. Is that right, John? That's my understanding.
In the specified namespace.
Yes. Well, you could do all namespaces, but there's no requirement that you have to do caches, right?
Yeah, it's a little vague on format.
Yes, yeah, it is.
There are a couple of things which are actually identified in IEEE 2883, if you are lucky enough to own a copy, that show the difference between NVM format with crypto and explain why we're considering it a clear, unless the vendor is giving some out of band indication that they indeed acknowledge or testify that they have covered the gaps in the NVMe format crypto that don't meet what IEEE 2883 requires for a purge.
Yeah, so to reiterate, it can be a purge, but it also can be a clear depending on the vendor implementation.
Mm-hmm.
And the only way to turn into a purge is if the vendor declares and communicates to the customer in question that they indeed did follow through somehow. It's not built into the spec. It's an add-on vendor-specific feature to turn that into a purge. Can be done.
Seems like there's some interesting synergies here with some of the stuff that the security group is doing around firmware security audits and Calyptra to kind of tie all these pieces together, I think.
Yes, I think if we were to start leveraging attestation, say if attestation passes and the device is clean, then we will repurpose it and not bother shredding it. I think we want some assurance that attestation is going to tell you a hash of firmware, and then I need to know, okay, is that hash good or not? That turns into an audit, I think. So.
And just to be clear, this is not meant. I mean, we've talked a lot about how do we kind of certify that sanitize is legit doing what it should be doing, so you can trust that when you sanitize something, and maybe you can measure that firmware and have that attestation to know that I'm running a firmware that's gotten, just like let's say FIPS, right? It's gotten a FIPS certification. It's gotten some other certification that we trust for sanitize. But I think what you're saying, this is a little bit different than tying a measurement of firmware to a known good sanitized, third-party verified. This is just saying, I am claiming that I'm a good sanitized purge firmware, and you can at least verify that I am the right firmware I say I am. And there isn't a third-party validation that it necessarily is doing a good purge, but it's just the SPDM bit that you're talking about would essentially just claim that I have done what I've claimed is a purge level sanitization. This doesn't go to the next step of trying to certify that third party so that I think a lot of the concerns have been financial customers, some of the hyperscalers, our customers certainly have been concerned that sanitize maybe is buggy, isn't implemented properly. And without having a third-party certification or validation of that code, that they don't want to trust it. And that's why they still throw drives and shredders.
Yeah, so I think that can certainly work together, right? So we can have, the third-party audit saying, yay, verily, this is good code, signed off on it. And then if that's all we have, then we can ship that known good firmware out to our fleet and be pretty confident that it's running out there, because we're confident that we're in control of our firmware updates. We can then layer on periodic attestation command or challenges to make sure that it's still running that firmware that we pushed out there. Cool. And then this status bit would allow us to tie it together and say, not only am I pretty confident that device is running my firmware because I tested it, a day ago or whatever, but as of right now, I'm definitely sure that A, it's running the right firmware, and B, it is clean. So off to the warehouse with it. And then the confidence I have in that that attested hash comes from the third-party audit having signed off on, yes, this hash means good firmware.
Yeah, Paul
Yeah.
said, yeah, you said it perfectly, Paul. I think in the future there will be an IEEE conformance assessment program to 2883. In the meantime, there's some third-party audits that do this. Jeff, that was why I was asking about some of the Redfish bindings, because these software tool suites that do these sanitize and these independent third-party auditors are going to need to know how to attest the firmware, like how do they send a Redfish command to get the firmware so they can read these bits. And that's because it's out of all the sanitize is done in band today through NVMe. This is done out of band. They just need some glue there to figure out how to do it.
Definitely. And actually, we have in the past we've talked about how to bind how Redfish works with SPDM, and we have been asked, hey, is there a reference code? I think it might be showing up in OpenBMC. I don't know when or if that's actually happening, but that's where I would look.
So Paul brought up a use case of a man in the middle. It allows the attestation to flow through just fine to say, yep, I got good firmware, and then it potentially blocks the sanitize and reports complete successfully.
Well, that's where the attestation would fix that. So if you block the sanitize command so that data is left on the drive, then when I go and do an SPDM challenge, the man in the middle can still block that. Then I'll be like, okay, well, I'm not confident yet, so crush it. But if they let the bits through, they can't cryptographically mess with it, and the bits will tell me that there, in fact, is still data left on that drive, and I'll still crush the drive.
So it definitely needs to be part of the attestation communication then.
Right. Yeah, that's why the whole, yes, it is valuable to be able to SPDM challenge these things on their own, just to give me periodic attestation that, yes, it's running good firmware, but if someone can suppress erase commands, then there's that vulnerability.
And are there drives? I know a lot of the drives support at least firmware measurement or TCG dice and some of the attestation. Do some of these drives, at least some of the newer ones, do this today, or is this completely new?
I am not aware of any particular drive models that do this yet. And I know that none of them do the status bit because that doesn't exist yet.
Right.
Yeah, so Jeff, were you sharing this to this is sort of where you were thinking of maybe adding a bit?
Yes. So here on the screen is SPM 1.2. We have some bits that have been allocated for operational modes and device modes. So this would basically turn into a proposal to DMTF to say, we have a use case for 1 or maybe 3 more bits. Let's please use them. I shopped this around OCP security to get their take. That spawned this conversation. So a question I would have for this group would be, like, for you implementers, if this became a standard and became something that customers asked for, is it a tall order to implement an SPDM responder that is aware of whether or not dirty data exists on the drive.
Can you validate that dirty data means customer LBAs as opposed to other illuminations of its drive's history, such as its lifetime history or power on hours or
I think that's reasonable.
prior write amplification or anything like that?
I think that'd be reasonable.
I mean, I think what we want this to be is essentially something that says I have been purged per the sanitize. You know, we've already done lots of good definitions in 2883 and in NVMe. So I think if we put that same language in to say that's what we want this bit to mean.
Okay, so just a follow-up question on that. So let's say the language says, you know, this bit is true if I have been purged. And I'm less familiar with like the exact proper meaning of that term, but can I then take that drive which has been purged and then go right to it, and then it just atomically becomes not purged?
I would say I am purged, not I have been.
Okay. So
we'll get into spec language here.
Yeah.
But here's you know, you can always go read that bit, but does that mean that by the time you get it, it's still purged? How do you guarantee that no more writes are going to occur when you're going to make that decision because you're looking at time?
That is true. So that is a true point. So if I'm worried about someone getting in there and writing some user data between when the challenge happens and when I unplug the device, I don't have a strong idea of how to address that yet in a lightweight fashion.
You would need a lock in purge state.
Yeah.
Yep.
And then lock it, then that gets into like, how do I unlock it for the next customer? Unless it's an unless it's a lock state that just autonomously releases itself on the power cycle.
Well, there are some TCG things you could start looking at that would either be like a PSID, right? You could essentially lock it, and then you have to have physical access of the device to enter the PSID from the label. They would then unlock it for the next customer, and that would prevent basically anybody from reading or writing to it. But if they have the device too, they could do the same thing. They could enter the PSID from the label, and then they get access to the drive.
Sure.
It depends on how you want to have kind of key management, and I use that word key loosely, but the password or key to the drive.
Yeah.
And how onerous you want to be with managing that key for the next customer.
Yeah, and that gets super hairy if it's not, you know, printed on the side, I think.
Yeah.
And as I've heard it, I haven't heard a good argument for actually. I've heard an argument for freezing it, which was an interesting concept, and I don't see any reason to gate unfreezing it. So at any point in time, you know, if you've gone through the trouble to purge it and you put it and somebody went through, the person who's going to pick it up and is expecting to see a purged device won't see it anymore. And somewhere along the process, somebody got mucked with it, and the new owner will know what to do. Either they're going to care or not care, and they'll purge it again.
Sure.
So
I mean, I think the concern would potentially be that somebody accidentally puts data on there that nobody knew about after it was purged the first time, and then it gets out in the wild, and then someone's got data that they didn't want out in the wild. I think that would be the main concern if you can't control it between the first initial purge and when you set the bid, or you know, however we wind up communicating that. They would say, I've been successfully purged, I'm free of any customer data. If that then goes and gets put on a shelf and somebody else accidentally grabs it, puts some data on it, didn't realize that was on the shipped out to the next customer shelf, and then it gets out, you know, that could potentially be a concern with, you know, not having some type of a lock or a freeze, I guess, that would prevent accidental reuse until it was actually meant to be repurposed.
Yeah.
One minor point.
But whoever was going to do that would have to knowingly unpurge it. And
Well,
if that
not
isn't
if
a
they're-
sufficient control, I'm not sure.
Yeah, unless there's
what
not a
would be-
freeze, right? If there's not a freeze, then they could accidentally unpurge it, right? They could just start writing data to it.
Yeah,
If there is
so
a freeze, then
the argument is, yes, there's a freeze, but everybody has permission to remove it, but it's an explicit command. So in
Right.
this case, somebody did something they're really not supposed to do in your system.
Well, or power cycle, right? You pulled it
Oh,
out.
no,
it's-
I would not remove it on power cycle. I would make hey, this device has been purged. I'm gonna wake up every time you tell me I'm purged, unless somebody has turned
Mhm.
off the.
It's yeah, it's a
Purge
little bit like the TP right now for NVMe sanitize, right? That Paul you're working on,
Yep.
to kind of put it in the verification mode. So if it stayed in that mode of I've been sanitized mode, that you can't, you have to take it out of that mode to read and write to it.
Yeah, you have
Yeah.
to explicitly take it out of that mode. Oh, by the way, one
well-
minor point, there already is in the existing sanitized definition a bit that says, I have been sanitized and nobody's written me again yet.
Mhm.
So simply reporting that to be, no, it's already available.
But it's
But
not
yeah.
locked. But it's not locked.
Correct. All these other problems still exist.
Yeah, and by the way, yeah, the way that companies like ITAD companies that are doing these decommissioning get around this today is basically they follow the ISO 27040 certificate of sanitization, which is basically the legal framework for how to say they ran this technician ran this sanitized software on this drive. They record the serial number, the date, the software used, all that stuff, and then they have that physical asset with that certificate of sanitization that says in some database that says here's when that was purged. But yeah, that's how it works today. It's not very automated, at least like from the protocol side.
Well, I think I have some homework to, as of this conversation, to go talk to some people at Google to understand how a persistent or a semi-persistent lock or freeze state would jive with our sanitized flows.
I'll also throw out one other thought about this. And that is, if you're doing this through NVMe, you can lock the stuff out. But if you just do it straight through SPDM, you then open yourself to attack, and that somebody can come in and start sanitizing drives, and you can't stop them.
That's why I like ideas of only using SPDM to report status out and not creating a channel to do things over SPDM, because then you have to get into who can talk to SPDM over what interfaces.
Exactly.
Yeah, if I'm aware, there is a way to do out of band sanitize through NVMe, but I don't think it's widely implemented or used. Maybe it's some OEMs, but
There's also a lockout. So
yeah, right.
Until
Okay.
power cycle.
Yeah. So, I think you hear in the shorter term, to back what Paul said, which is there are going to be these independent third-party audits for the sanitized commands that we have today in NVMe, and being able to basically say that a drive did attest to the firmware that actually passed that compliance or third-party audit is still valuable today, even without some of the other things you talked about. Mm-hmm. And that flow isn't well understood by the people running the software.
Meaning, like, yeah, get all that glue in place. How do I challenge SPDM?
Yeah, exactly. And I think that's also valuable, by itself as a doing attestation to a firmware version that's known but audited.
Yeah. I will say, we did try. Like, SPDM is not the nicest of protocols to expose off machine. It's kind of chatty and intended to be two things on machine talking to each other. We made it work with Redfish, but it's not the most ergonomic thing. And we tried to modify SPDM to be more amenable to nonce in, signature out. But that didn't make it into 1.2, and we haven't yet had bandwidth to re-attempt that. But like, compare that to, say, for example, TPM, where well-defined nonce goes in, well-defined struct comes out. I can package that up. I can serialize it, deserialize it, verify signature on it. It's fine. SPDM is a lot of back and forth transcript stuff going on. So yeah, make it work with Redfish, but it does need some tooling to get done.
Yeah, and I mean, just to kind of, you know, Redfish really is an outside the box kind of thing. So for authenticating drives, it's really going to wind up being, you know, drives don't support Redfish. So what really happens is the BMC gets that Redfish command, it translates that into an NVMe MI or SPDM command, depending on what kind of command it is, and then it talks directly to the drive. So from a, you know, validation perspective, it's going to be tougher for someone that's trying to do a sanitize validate inside a box to use the Redfish mechanism.
Yeah, and I think we wouldn't even expect that to be done if you're in the box.
Yeah, I think right. You'd have direct access to SPDM, and so that's what we'd be doing. So I think that would make it easier because they don't have to go learn all the Redfish schema for how to do this. It would really just be if you're doing validations and you're trying to do that, you know, whether it's a third-party house or whatever, they're writing software tools to do that, and it's inside the box, then it would just use the direct SPDM commands.
Absolutely, yeah. Redfish would only be needed once it's in the control in the field, and we need the control plane to talk to it, and we need an out-of-band mechanism.
And you could do MCTP over PCIe for SPDM, right? So you don't have sideband connection to BMC. Okay. And Mike, was there any talk about doing attestation stuff in NVMe directly? No,
not yet.
Would that be
send T-part?
Yeah.
Are you volunteering here?
There is no tie in NVMe or NVMe MI to SPDM right now. Nor is there, am I aware of any TP, nor of any discussion of doing that.
And you kind of see where I was going.
We have talked about it and what's appropriate, and we haven't come up with any use cases for SP in MI yet. And that would be a place to bring it in.
I mean, there is. I think most people here are probably aware of the work that's going on in DMTF, the SPDM working group right now, to bring it into SAS and SATA. You probably heard me harp on that a handful of times that's needed, and that is also that using over the security send and receive would essentially very easily work itself into NVMe in that same mechanism. It's being looked at for NVMe over fabrics to be able to take those in through the security send and receive commands for SAS SATA, and then that it could easily be extended to NVMe. That's kind of an ongoing, it's very early work. It's not very far along, but that is being done right now.
One of the discussions in PCIe, though, is that PCIe has other mechanisms that are not NVMe specific, and PCIe may want to have one consistent mechanism. And those mechanisms, and there are already several, are not available to the security over storage, which is why they're inventing the new one. That does not necessarily mean that it's advantageous to use for NVMe. And that's absolutely needs to be an ecosystem discussion, but it's more than just storage vendors because it's PCIe infrastructure. It's the way that's typically looked at as opposed to the storage infrastructure. And that call needs to be discussed and debated appropriately.
Yeah, and right now we don't, I mean, I think that's why the focus in that work group is somewhat SAS and SATA, because there's no way to do it today for SAS and SATA.
Right.
There is a way to do it for
It's an
NVMe,
enabler for SAS and SATA. Yeah.
It's easy to extend to NVMe, but we don't really need to right now because we have the PCIe mechanisms. And as we get PCIe DOE and new ASICs, then we'll have even ways that the host can directly authenticate. So you'll be able to have, you know, VMs that could directly, you know, authenticate its virtual functions through DOE versus having to rely on a control plane only. So I think there's a lot coming with the PCIe based infrastructure, but that could also be done in band over NVMe using the same mechanism that they're working on right now in DMTF.
And OCP security has asked us to actually concentrate more on the out of band, the I2C, I3C sort of world instead of over VDM. I presume that recommendation still stands from OCP security.
Well, that would
Well-
accept HDDs because they don't have an out of band method today.
Yeah, but for PCIe and NVMe devices.
Yeah, yeah.
Yeah, I think there's quite a few moving objects around that as far as being able to support securely authenticating PCI VDM, where you've got busmaster bit disabled and things, so that, you know, if a rogue device came on, I think there's some things that we've been talking about as well, and how you can improve some of PCIe's functionality to limit the access that a rogue device might have to PCIe if you were going to authenticate it over VDM, so that it can't plug in and start, you know, doing DMAs and scanning all your memory. And I think that's where the interest in, you know, doing it totally sideband, totally physically different interface, I think that's where that's coming from. But I think there's mechanisms that we're looking at to improve PCIe, some of the features like SFI that would enable a much more robust, secure way to still do things over PCI VDM, as well as SMBus or I3C.
Well, on reflection, with these status bits, I think I can think of at least the ask for how many bits started as 1, but I think could balloon to 3 or even 6 more bits, like lock status, various kinds of sanitize. So now there is room, right? There's, you know, there's 32 bits here, and we're only using 5 of them. But I'm wondering if it'd make more sense to define a whole new kind of measurement block that holds just bits for if you're a storage device, you can have these. I don't think that's a high. I don't think that's a very critical decision point for the folks in this room. It would just be what kind of spec work gets done. But it sounds like it's implementable, what I'm hearing. And there's a lot of plumbing questions between the responder and the verifier and everyone else, but at least from the device's perspective, this sounds doable.
Sounds like the proposal is a sanitize and lock, followed by some method of unlocking.
Yes, sanitize, lock, attest that you are sanitized and locked, and then go unlock yourself. Or get unlocked somehow.
So Paul needs another state. Sorry, Paul.
More than that.
That's an NVMe joke right there.
But yeah, Jeff, even
I thought it's not the states, it's the transitions.
I'll ask Ross and Mike about this one. What about anything in telemetry? Are we just assuming it was never contaminated in the first place?
I think that's a very big topic, but it's probably outside the scope of this meeting.
Yeah, yeah.
I think even
Audit should say it's free of LBA clear text.
yeah, even bad blocks and other things are a pretty large topic.
You can go into log pages and all that other stuff, right? Not just telemetry.
well, it's a good Ross. This question for you, right? Is do we are in the storage work group? Do you guys want to put a list together of like hyperscale sanitized requirements that are, you know, above and beyond what, you know, normal folks need?
I mean, today we have security requirements, but there aren't plans to go past that. But, you know, plans change with time. Okay, Jeff. Appreciate you coming in.
Yeah,
and it was a good discussion.
It was actually fun discussion. Appreciate it.
In part.
Anything else you wanted to ask for us today? Otherwise, I think we are done for the day.
Let's do this again sometime.
Okay, well, thanks for
Maybe a
coming and
month.
joining us today, and appreciate you coming in.
Have a good one.
All right.
Thank
Bye.
you.
Thank you, Jeff. Thank you,
Thank you,
Ross.
everybody.
John Michael.
Thanks,
Bye-bye.
everyone.
Bye, everyone.
Lovely to be a fly on the wall.